Video, we will learn about a buck converter. Buck converter is a step-down transformer which converts DC into a DC, but higher input voltages will be reduced to a lower voltages and lower input currents will be increased to higher currents. Now it is somewhat similar to a step-down transformer in the case of AC. For example, if you have a step-down transformer which takes an input voltage of 24 volt and gives an output voltage of 12, and it is having an input current of 3 amps, then it gives 6 amps of output current. For this particular transformer, we consider that the turns ratio is 2:1. That means the output voltages are half and output currents are double that of the input. But in this particular transformer, you will have input power to be exactly same as your output power. So the transformer in case of an AC is a power invariant device which just increases or decreases the voltages from input to output, and similarly does the same for the currents in an inverse manner by keeping the power input and power output constant. So similar to that, this buck converter is a DC to DC converter. So your input is DC and your output is also DC, but it can work like a transformer where if you're giving 24 volts of a DC power supply, it can transfer that into a 12 volts of DC output. In the similar case, if you want to look at how the currents are being transferred, then you will have, for example, if you have an 3 amps of input current, in case of a buck converter, you will have 6 amps of output current. But even in the case of a buck converter, you can say that your input current is exactly same as your output current, excluding the losses. So this is the fundamental principle of your buck converter. So how do we achieve that buck converter using the power electronic switches and filter components like inductors and capacitors? If you look at the circuit diagram of the buck converter, we can say that we have our input voltage here, similarly our output resistance here. In between these two, input and output, or the source and load, we have the particular circuit diagram which converts that higher voltage levels of DC to our lower voltage levels of DC. If you observe the components involved in this particular buck converter, one is the switch for us. So that's a switch. And then we also have a diode. The next component that we have is an inductor. And the other one that we have is the capacitor. So out of all these 4 components, we try to design this buck converter by appropriately selecting the parameters for this elements. Now for suppose if you want to look at the switch, then in the case of a switch, we wanted to know what is the switching frequency and also a duty cycle. The next, in the case of an inductor, you wanted to know what is the value of an inductor. And the third one is, in case of a capacitor, you also want to know what is the value of the capacitor. By observing this particular converter circuit, you understand that these are the 3 major elements to be decided if you want to design a buck converter. Now, it is very clear that out of all these 3 elements, duty cycle is something that regulates the output voltage, and inductor is going to regulate the amount of current ripple that you get in your output, and the capacitor will regulate the amount of voltage ripple we get in our output. So if you wanted to know what is the amount of duty cycle you need to put into your buck converter, that will be decided based on the transformation ratio that is required in case of a buck converter. And if you want to decide what is the value of an inductor, the value of the inductor will be decided based on the allowable variations in your output current or the ripple in your output current. Similarly, the value of the capacitance will be decided based on the allowable voltage ripple in your output voltages. So we'll try to get what are the mathematical expressions for the output voltage as a function of a duty cycle, That means we would like to get what is our V naught as a function of duty cycle, let's say D, as well as the value of the inductance as a function of the current ripple that we want, and the value of the capacitance is going to be function of the amount of voltage ripple that we expect. So if you decide what is your output voltage, then you know what is your duty cycle. If you decide what is your current ripple requirement, then you know what is the value of your inductance. If you know what is the voltage ripple that you allow in your circuit, then you will be able to decide what will be the value of capacitance in your buck converter.